wants to learn how to use .NET Core 3, then you should definitely buy that book, although it's a little bit out of date for obvious reasons. Contact me on Twitter, LinkedIn, and I run, as Joshua pointed out before, a little meetup group called MiniHack, so please come along to that. Okay, so I'm going to do some live demos today, and you know what I say about demos, you shouldn't do them. They're dangerous, stuff goes wrong. So what I want everyone to do is to pretend that everything kind of worked fine and we'll just move on, not speak of it again. One of the things I wanted to try on this was an interactive poll. Josh, I don't know if you could just repost that that link.
Yes, I'm hoping it's still in my clipboard. Won't be that.
It don't matter if it's not, I've still got it.
I've got it. I'll post it to everyone now.
Cool.
Here we go.
So I've got a couple of, I assume everyone can now see that. Yeah. All right. Okay. You can see the results. So somewhere here, I've got the, that's it. Cool. Okay. So I don't know how many people are actually here, but we've got about 7 people are using Service Bus where they work. Oh, we're still going. Right. So have you used it before? This is like basically the virtual equivalent of me saying hands up anyone who's like used it before. Cool. Okay, so everyone has used it and everybody likes it. That's good. Well, all apart from 3 people. And the next one. Okay, so regarding the demos, everybody needs to enter into a legally binding contract that it'll ignore any failures during this presentation. It looks like I'm buying some pints at the end of this, doesn't it? Cool. Okay. So that seems to be working quite well. Right. Okay. So I'm making some assumptions about the people who are in, and it seems from what I've just seen on that survey that they're relatively valid. So I'm sort of assuming that you're familiar with the basic principles of a message broker, and you know what Azure Service Bus is, and you at least sort of got to the stage where you kind of know what a queue or a topic is. So what I wanted to talk about in this talk is some of the sort of lesser known features, and or maybe not lesser known, but kind of features that you can go into Service Bus, you can set up a queue, you can add some messages to a queue, and then at the end of it, you cannot have done any of this. You cannot even know that any of this exists, and successfully use Service Bus. But all of these things are there, and they're kind of out of the box, so they can be quite useful if you kind of learn what they are, and hopefully we'll go into some details about them. Okay, so start off with dead letter queues and transactions. So dead letter queues, what are dead letter queues? So in a normal queue, I mean, I've just finished saying that. I'm assuming everyone knows what a queue is, and then I'm going to kind of tell you what a queue is anyway. So in a normal queue, what happens is messages come in and they essentially get processed. So you can think of it like a conveyor belt. So I've got a little PowerPoint animation here. So the message comes in and it gets consumed and it goes into a bucket. But then at some point, a message comes in and there's something wrong with it, and then nothing can happen. So the consumer is trying to consume that message. It can't, it gets stuck, and the queue just backs up. So the idea behind a dead letter queue is exactly what you would do if this were a real conveyor belt. So you have a bin, basically, and the messages come in. They go into the bucket as before, and then you get one that doesn't work, and the stuff starts to build up behind it. That goes off into the dead letter queue, and forgive the PowerPoint animation, but then kind of the queue can continue as previously. Okay, so what this is, there's a lot of reasons. I mean, this isn't an exhaustive list as to why that might happen. The top two are really the ones that you should you're most likely to come across. So either usually you explicitly put something in the dead letter queue for some reason, or the max delivery count is exceeded. So effectively this, and we'll go into a demo with this, but effectively this is, it tries to deliver it, you tell it how many times to try and deliver it, and then after a bit it goes, I'm not trying anymore because this clearly isn't working, just get dead letter. There are other reasons. For example, it can expire. If you've enabled sessions, which we'll come back to, then and the message doesn't have a session, then it'll dead letter. And we'll come back to auto forwarding, but if you forward it more than 4 times, and we'll come back to why that is. Okay, so I mean, I'm guessing a lot of you have seen this screen. I'm not going to kind of mess about in the portal in this session, but basically you create a queue, and you sort of get a dead letter queue with it, whether you like it or not. It's kind of part of the structure. This, I'm assuming everyone can see my mouse. This enable dead letter on message expiration. You don't have to have that ticked. It makes no difference. Well, it does make a difference. It makes a difference in that expired messages don't get dead lettered if you don't tick that. But other than that, it's a simple process to create a queue. Okay, I'm going to come back to why I'm talking about transactions in the middle of dead letters, but I just want to sort of briefly explain what a transaction is, and then all will become clear when I get into the demo. So kind of remember everything I've said about dead letters, and then just put that on one side. So a transaction, I mean, anybody who's worked with a database kind of knows what a transaction is. So you have multiple things that happen in sequence, and then they all work or they all fail. And you can do the same thing in Service Bus. So you can say these messages are all being sent as a transaction. So if the transaction fails, then no messages will be sent. And if the transaction succeeds, then obviously succeeded, all the messages have been sent. Cool. Okay, so we've got a demo. So just bear with me while I do some screen swapping. I think I need 4 monitors rather than 3. Okay, so I'll come back to the code in a minute, but basically these all of these demos work off the best UI framework that I've ever come across, which is the console app. So I'm just going to bring into play here a piece of software that you might be familiar with. This is the Service Bus Explorer. There's a version of this online as part of the portal, but it doesn't kind of work as well as the version that you download. And this is really out of date. I mean, it's several years old, and it's written in WinForms, but it's still the best thing out there that I've found, especially if you're kind of messing about with some of the more advanced features. So I'm going to send the message to dead letter demo here. So there you can see the queue is there. So let me actually just clear that so that okay, so we've got an empty queue. So I'm going to send a message, and then we should see that pop up in the dead letter demo. So now what I'm going to do is I'm going to explicitly abandon abandon the message. I'll show you how we're doing that in a minute. But when I do it, you'll see that it's sort of saying, okay, we've got a delivery count of 1. And this particular message, the max delivery count is 10. So I'll keep on doing it. You'll keep on seeing this number go up and up and up. And when it gets to 10, we should see that it's dead lettered. Okay, bear with me a sec. It's quite annoying that because I've got my notes on the other screen, so every time I click on it, it changes focus, which is a little bit inconvenient. Okay, so the next thing, I suppose, is to send a letter and then send a message, which is now in there. And this time, what we're going to do is we're going to explicitly dead letter it. So I was saying this is one of these are effectively the two reasons that I was saying you're probably going to end up with a message in the dead letter queue. And this time it just immediately dead letters the message because we've kind of told it to. And then I've used the API here to sort of show you that you can see what's in the dead letter queue. So when I press that, what it's done is it's gone and had a look at the dead letter message. It tells you why that message has been dead lettered, and that can be quite useful actually, seeing sort of being able to programmatically see what's in the dead letter queue. And then I've got a resubmit here. Now, resubmit isn't really a resubmit. It's a cheat, and I'll show you why in a minute. But yeah, so they're kind of the functions that you can sort of do on dead letter. So let's have a look at the code and see what it's doing. Cool. Okay. So yeah, there we go. So yeah, I mean, again, brilliant UI framework. This, I don't know why everybody doesn't use it. I mean, React is like, it's got years before it's this good. So okay, sending a message. There's not really much to get into there. I'm just sending a message. This is using the .NET Core SDK. Nothing particularly interesting to write home about. And then reading the message, slightly different. So in this case, what it's doing, instead of completing the message, which would be the normal situation in the message you get removed from the queue, it abandons it. And that, I don't know if you've seen this sort of syntax, but basically when you've got the message, you need this lock token. This lock token's like magic. So anything you want to do with the message, certainly in the .NET Core SDK, you do it via the lock token. So pretty much every function is based on the kind of, you don't do it on the message in the .NET Core SDK like you did with the previous one with the framework SDK. You do it either on the receiver or the queue client, and you just pass it this lock token. So yeah, you can abandon it, and then that'll just basically increment the delivery count. And so this is the explicitly dead letter in the message. So again, same process. You've got the lock token in the message. You call this dead letter async. Everything's async these days. And yeah, that just sticks it straight in the dead letter queue. And then we come on to the read dead letter message. So this is an interesting one. So this entity name helper is effectively a helper class, and you sort of need it to do anything with the dead letter queue other than just put stuff in it. So what this will do is it'll give you the kind of it'll give Service Bus the path to the dead letter queue. And then you just set up a normal message receiver like you would with any queue, and you receive the message from the dead letter queue. And we'll come back to these user properties later. But yeah, so essentially what I'm doing here is I'm saying, okay, read it and then just tell me what the dead letter reason was, and the description, and then tell me the delivery count, just so that when I'm pressing whatever it was, number 4, I know when it is. And the last bit is the resubmit. Sorry, you'll notice that the screen keeps on just kind of going off because it's when I'm clicking on my notes. So if we have a look at the resubmit. So, you know, I absolutely hold my hands up here. This was not just me formulating this. This is standing on the shoulder of giants here. So essentially, it's the same thing as when you're sort of reading the dead letter queue in exactly the same manner, and you'll see as I go through this that it is a bit of smoke and mirrors, because it's not actually resubmitting the message. What it's actually doing is it's establishing a transaction here. So we've got a transaction scope, and I'm completing it here on line 90. So essentially everything that happens between there has got to either happen or not happen. So what I'm doing is I'm cloning the message that's in the dead letter queue, and then I'm removing the errors from it, and then I'm just posting it again. So I'm not actually resubmitting it. I'm just causing it to copy the message and then kind of go again. One thing we can do just to prove that this kind of either works or it doesn't work is if I stick that in, yeah, that should run. If I stick that in, then the actual transaction shouldn't complete, and then it shouldn't resubmit the message. So let's just see the Service Bus Explorer. So let's get rid of what's in there. Oh, there it is. Okay, and then so now I can send that message, and then I can dead letter it. So now we've got a fresh dead letter message, and I'm going to resubmit it. Now obviously this is going to crash. Let me just play that through, kill it. What we should see is that that's not resubmitted it, and the reason it hasn't resubmitted is because of that transaction. So the transaction failed, and despite the fact that we'd already done the cloned the message and then sent it, because we couldn't complete it and an error happened, nothing in that transaction happened. Okay, so that's dead letters. Okay, so that's kind of how you deal with dead letters. But I suppose the next question is what you would do with them when you get them. And in true IT consultant style, it depends. So obviously, if you've got a load of messages and I don't know, feeding through for some spam bot to send emails or something, and you get one of them dead lettered, the correct answer might be leave it or just trash the dead letter queue or something because you don't really care. But what you should probably do is you should probably tell someone about it, and you should probably log the event. I'm not going to demonstrate this, but one way you could do that is using a logic app, and you could pretty much do that out of the box. So if you go into logic apps, you can just bulk it directly up into a service bus queue. You know, you select your namespace, and then you give it the connection name, and then you just tell it to send an email based on anything that goes into that dead letter queue to whoever you want. So it's not a brilliant solution, but if someone comes to you and says, can you do something with that dead letter queue in the next 12 seconds, then you can. Okay, cool. So that's dead letters. The next topic is scheduled and deferred messages. So these essentially, the idea behind these are messages that are either not sent or not received when you would expect them to be. So scheduled messages, essentially this allows a message to be passed to the service bus but sent later. So for example, the email spam bot that I've just mentioned, that's a good example, because you might want to email people at intervals or at certain times of the day. You might also want to use this for something a little bit less nefarious, like you might want to retry a dead letter message, as we've just shown, but you might want to back off the retry in case there was a transient failure. So in the sort of resubmit code that we just had, you might feed that into a scheduled message and say, actually send this message back in 10 minutes time, in case, you know, there's some issue that's kind of time related or whatever, or related to the time that it happens. Okay, so scheduled message demo. So I actually wrote a blog post on how to change the startup or run these projects with just a key combination, and I created a key combination, a custom key combination, and I've forgotten what it is, and I always do. So okay, so guys, this is a relatively simple demo. So effectively, I'm going to set this up to receive messages based on the event style of receiving. So there's two ways of receiving a message. I'll go over that in a minute. But so that's set to receive messages. I'm now going to send the message. And what's going to happen is it's going to look like nothing's happened. But I'm going to keep on waffling on for a bit. And in about 10 seconds, something should appear here. Yeah, there we go. So effectively, I set that to send in 10 seconds time, and then kind of get received by the same application. So let's have a look at what's going on there. So in terms of this read message, so effectively with Service Bus, you've got two ways of receiving a message. So you can kind of poll the message queue and say, I would like the next message that you've got, or you can set this sort of message handler up, and it'll just, any messages that come into the queue, it'll raise an event, and then you kind of have to deal with that. And you can use either one, either using peak lock or receive and delete. So the difference being that peak lock effectively locks the message, and then you have to explicitly say I want to complete that message. Whereas receive and delete just assumes that you've kind of successfully processed that message. So all this is doing, it's not really worth explaining the receive part of it, because it's just handling the message and displaying it to the screen. But the send message is a bit different. So all we're doing here is we're saying, okay, set up a queue client, create the message, and then just send the message here. And the reason this returns a sequence number, and I say you can use that to then cancel that schedule. So you'd say that's going to send in 10 seconds or whatever. Now, if in 5 seconds I realise that, oh no, I don't want to send this message or whatever, I can cancel it, but only with that sequence number. And that becomes more important. It's a similar process with deferred messages that we'll go into in a sec. That it becomes quite important to keep that code. Cool. Okay. Just coming back to custom user properties. So you sort of saw this before when I was doing the dead letters. You saw that it had reason failure, failure reason, whatever it was, dead letter reason. They're effectively custom user properties, but the ones that the system kind of uses for you. But you can pass your own in. Okay, so and I will explain why I just mentioned custom user properties in a minute, but it wasn't kind of just random. Okay, so deferred messages. So this is the situation where somebody is, or not somebody, but something has sent a message, and as the receiver, you're not ready to kind of process that message. So the typical example of this is in an eventual consistency scenario, because you've got some kind of processing going on in the background, and somebody sends a service bus message or whatever to say do something with this data, and you look at that data and it's not ready. So maybe somebody said update the address on this record, and you look there and there's no customer that's been created yet. So you can effectively say, okay, I don't want this message now, but I don't want to lose it, because what you're asking me to do is probably kosher. It's just not kosher at this minute in time. Okay, so let's see how that works. Okay, so so same excellent UI. So this time we're going to send a ready message, and we're going to send a not ready message, and then what we're going to do is we're going to look at what it's done in the Explorer. So this is the deferral queue. Okay, so there's 2 messages in that queue, and one's ready, one's not ready. And so what we're going to do, if we have a look at the actual messages themselves, so we can see some properties here, and as one of them, custom user property that I've added, is ready. Okay, so that's nothing to do with the actual service bus. I've added that is ready property, and I've said for this one it's true, for this one it's false. That's just kind of my crude way of sort of differentiating the messages. So it's all coming around. I mentioned custom user properties, and now I've used them. Okay, so let's get back to that and that. Okay, so the next thing is I'm going to receive the ready message. Okay, so what's happened now is one of the messages has effectively been received, and then what you'll notice if we have a look at the at the messages in that queue, we should see that the remaining message is kind of still there. And then what we're going to do is we're going to receive the not ready message. So what's happened now is that message is still there, but it's now in a state of deferred. I think we should be able to see. We should be able to see that it's deferred. Can't quite see the property at the minute. I just need to. Yeah. Okay. Effectively, that message is.
I just saw that then. I just saw it was deferred. Just go straight to the bottom. There it is, state.
That's it. Yep. Excellent. Thank that man. Yep. Okay. So it's deferred. And effectively, I can now receive that by pressing 4. And then just nip to the bottom of these notes. Yeah. So then I can receive that, and it should receive that deferred message. Cool. Yep. I won't clean the message. I'll explain why I've got a clean message in there. It'll sort of feed into why you should be careful when using deferred messages. So let's have a look at the code. Okay, so again, not a huge amount to see here, except for that user properties that are sort of introduced. As far as I'm aware, the only 2 sort of system user properties, if you like, are on the dead letter message. But you can use this as just a key value pair store to pass stuff through. The interesting bit is the receive and defer. So effectively, this just checks that user property, but then it gets the sequence number and it defers it. And this sequence number is important. This sequence number is so important that if you don't have it, you can never ever get rid of that message. It just sits in that queue forever. Service Bus Explorer that you've just seen will not clear that queue. In fact, it'll crash if you try and purge it and it's got that queue in. The only way that I've come up with to get rid of it, and if anybody knows a better way, then let me know. The only way I've come up with to get rid of it is to actually give it the sequence number. So Service Bus Explorer will tell you what that sequence number is if you kind of have a look. And so I created this just so I could clear it out when because obviously the sequence number here is held in memory. So if I close this down without sort of persisting that sequence number, then I'm kind of knackered. So that's kind of deferred messages and a warning to not take that sequence number lightly. Okay, so sessions. So sessions are an interesting little feature. They're effectively a virtual queue. So the idea behind sessions is that you'll establish a session, and you can send a message to that session, and only subscribers to that session can see that message, if you like. So it gives you a few things. It gives you guaranteed FIFO. It's opt-in or opt-out, so queues have got to be session aware. And you can't use it on the basic tier, so you kind of have to pay a bit more for it. and it was designed for the request response pattern. So effectively, the way it works, you've got a number of messages here. They're all on different sessions, and it just treats them as two virtual queues. And you can, I've put a sort of PowerShell AZ command here. Effectively, what I'm trying to illustrate is this: that you need to have a session enabled queue to use sessions. If you haven't got a session enabled queue, you can't use sessions. And if you think back to when we're talking about the dead letter queue, one of the reasons for a dead lettering is that you try and put a session enabled message on a queue that doesn't support it, or vice versa. Okay, so let's see what happens with sessions. Okay, so before we do this, it's time to go there we go. So session queue demo. Okay, so what I'm also going to do is I'm going to advance that poll, and you'll see why in a second. So I'm going to send some messages. And then we'll have a look at what that's done. Somewhere. There we go. So queue session demo. So we've got a couple of messages. And you'll notice that if we have a look at these messages, one of them's message and one of them's just, I don't want to know about it. It's just noise. So what I'm going to do now is I'm going to receive the message from session 1. And what we should see is that only one of them messages has been received. It's a bit annoying that you have to kind of re-receive the message, but yep. So the kind of the noise message is left. It's and the main one has been removed. Okay, so on this one, there we go. Okay. So what we're going to do now is we're going to launch a second instance of this. Can find Azure Studio. Okay, so we have 2 instances. And in this instance, I'm going to send a message and I'm going to wait a reply. This is the request response pattern, effectively. And then in the second instance, I'm going to receive that message. 4. Okay, so I've got a message through here, and this is where I'm going to advance this poll. So who knows who performed that song? Get the results up. Come on, someone's got to know the answer to that. No, nobody. Oh, maybe. Yep. Okay. There's 3 Rainbow fans in the audience. Oh, okay, it's timed out. Let's redo that, but not hang on. Okay, so this is send the message, and then here we're going to receive it, and then this time we're going to reply, and then you'll see that this instantly kind of kicked in and said, "Yep, okay, it's Stargazer Rainbow" when we sent the reply. So one of the ways that you can use this is you can use it effectively like a synchronous call to an API through Service Bus. So what you can do is you can say, I'm going to use a session to call my API, whatever it is, and effectively await the response, but via the Service Bus. So you've got the asynchronous sort of abstraction, if you like, but you can still sort of execute things in synchronously if you need to. Let's just come out of these and see what that code looks like. Okay, so again, send message, not a huge amount to write home about except for this one property. And then again, you know, the read message, instead of being receive message, it's accept message session, and you have to tell it which session you want it for. And if we go back to there, so what we're essentially doing there is we're saying, okay, we're going to with that sequence that I just showed, we're going to send a message with, you know, with a string or whatever, and we're going to send it on this sort of session, and then we're going to wait for it back on this second session. And then what we did was we said, okay, as a reply, we'll send it back on the first session, and then when it was kind of acknowledged, then we use a second session. So you've effectively got a single queue, but you've split it into two. So you've got one send and one reply, and that's pretty much what sessions were kind of written for, to have this request response pattern that I think people were using message brokers for anyway, but via other means. Okay, so that's sessions. So Service Bus management. There's actually 3 topics here. We're talking about Service Bus management, but we're also talking about ways that you can kind of auto delete and auto forward messages. And the reason they kind of go together is because what you're essentially doing is you're changing the sort of structure of the Service Bus, if you like, in code. So this was actually a lot easier to do under the Framework SDK. And when they released the Core SDK, I think they decided that we don't want people who are just consuming messages to necessarily be able to create a queue at the same time, although it was incredibly useful to do that. So yeah, so Service Bus management. So it allows you to set up things like queues and topics in code. And this is it's a bit like, I think of it like Entity Framework. So you can write your code such that when you run it, if the queue that you're trying to write to or read from doesn't exist, it'll just create it. And then like I say, it's separated now from the code that actually uses Service Bus. Although there's no reason you can't use both in the same application. So auto delete on idle is one of these other features that I mentioned. And this is essentially when you've got a queue or a subscription or topic that you kind of don't expect to live for very long. What you can do is you can tell it, okay, if nothing happens in this queue in 20 minutes, just get rid of it. And then the next time I come back, use the previous slide we were talking about the management. I'll just create it next time or something like that. So an example of this might be, say you've got an event that's happening and you're sending emails. You might want to just get rid of that queue, or if you've got some kind of session, for example, that we've just demonstrated. So maybe the acknowledgement expires after 3 hours. So maybe if nothing's happened in that queue in 3 hours, then the queue just goes. And it's worth bearing in mind that this applies to the queue. It doesn't apply to the message. So you can also separately say to a message, dead letter after a certain period of time. But this basically trashes the queue if nothing's happened to it in a certain period of time. And the last of these is the auto forwarding. So this is essentially you put into a queue when you get a message, send it somewhere else. And this can be used for a number of different reasons. You can use it as a buffer, so you can send all of your messages to a single queue, and then you can kind of put some logic in to say, okay, we'll send it on to whatever a topic or something like that. And you can effectively decouple your sending code from the transmission. It's also quite useful if you decide you want to do some re-architecting. So if you've got a queue that's there and you decide you want to change that queue, you can set up a forward so that it'll kind of go to the new queue, and you don't have to change the code that interacts with that queue, if you like. Another good use in centralized dead letter queue. So all the dead letter queues have got all the dead letter queues have got an auto forward to a single one or a single normal queue. And this we mentioned this before about the 4 forwards. So it's not hard to imagine that if you start messing about with this stuff, you would end up with eventually a situation where you infinitely forwarded it round and round and round in circles, and the whole of Seattle starts having lights dimming because you're just forwarding your message round and round the circle. So after 4 times, it just sends it to the dead letter queue. So this is an illustration of what I was saying about effectively you've got a message, it goes to a queue, and with it auto forward, one thing you can do is you can say, okay, this queue, delete it when it's idle, and just start moving the messages to this new queue. Okay, so let's see a demo of this. Okay, so let's just check that we haven't got these in existence. So what we're going to do here is we're going to dynamically create a queue, and what we should find, probably set the where is it there? Okay, so what we should find here. So if the first option here is to delete queues, so it's going to try and delete some queues. If I do that and the queues don't exist, then it'll crash. As it happens, they did exist. So what I'll do is I'll create them again. and we should see them just pop back to life. Yep, there we go. Okay, so what we'll notice here, if we have a look at the source queue, there should be an auto forward option. Ah, there we go, forward to. So here, so when it created it, it's just basically forwarding it to destination. So if I now, so before I do that, let's, yeah, okay. There's got to be a way in Windows to just say, like, Control and Z on the screen change that you've just done. Just go back to the last set of the screen. Okay, yeah, so one thing I can do is I can, and I'll show how this kind of works, but these queues that I've just created, I'm having a look at the connection details there, the same way as you could in the portal. Come back to that. It's a little bit out of sequence as well. I probably should have had that last. So if I send a message to the source queue here, what we'll find, or what we'd expect, based on what we've just seen, is that actually it doesn't go in the source queue, it just goes straight to the destination. Okay, so let's see what we've got in here. So what message is appeared in here? Okay, so we've got some more lyrics in here. So I'm going to advance the poll again to see, test some music knowledge here. There we go. So what is the title of this song? Two people. Has everyone gone to sleep? Oh. Okay. Right, it is actually leaving here. It was on the On Parole album by Motorhead. But something I didn't realise until I started doing this talk, it wasn't written by Motorhead. And it was actually recorded by The Who as well at one point, which I didn't know. And it was a massively inferior version, to be fair. Anyway, that's that. Okay, so let's so back there and there. Okay, so right, so now we're going to set up an auto delete queue. One of the problems with an auto delete queue is I think the limit, the least amount of time that you can set it to is 5 minutes. So what I've done is I've set up a queue that's going to auto delete in 5 minutes there, and I've sent some messages to it, or I'm sending some messages to it, still sending. And in 5 minutes time it should delete. So if someone could be so good as to remind me before the end of the talk, or at least perhaps when I've finished doing the demo, to come back to that queue, that would be excellent. Right, so let's have a look at the code for that. Actually, I should probably check it's sent all them messages before I do, just so that. Yep, okay. So stop that. I'm going to have a look at Service Bus Management. Okay. So I suppose the first thing that you should probably see here is the packages. So what you've got with all of these is Microsoft Azure Service Bus. That's kind of the magic SDK package that does everything, if you like. But in this one, we've also used Azure.messaging.service bus. The management story is a bit of a mess. There's 3 separate packages that do the same thing, and that's only for .NET Core. There's obviously some stuff for framework as well. This is the one that Microsoft recommend that you use right now. So, if this is recorded and you're watching it next week, that advice might have changed, or there might be 3 new packages next week. But at the minute, that's what they recommend. Essentially, yeah. So once you've got that package installed, everything else is relatively straightforward. So it's based on this Service Bus administration client, and once you've got it, you've got kind of a lot of the options you'd expect. So, on remove queue, I'm just calling delete queue async. And if you have a look, the options here are the sort of ones that you would have, if you've used the framework one, the sort of ones that you would expect from there. So, it lets you kind of mess about with the structure of the queue. So that's remove. Let's follow it through in sequence. So creating an auto folding queue. Again, same process, setting up the Service Bus administration client. Here, I've set up an authorization rule. This is the equivalent of in Portal. There's an option of shared access, and you go in that and you kind of see your rules, or you set up your rules there, and that's kind of how you get your connection string and so on. So effectively, I'm setting that up, connecting the administration client, and then I'm creating these queue options, effectively using the queue that was passed through as a destination, and then I'm adding that authorization rule that I've declared further up. So all I've really done at this point is I've told it what the queue's called, how I'm going to access it, and then I just create it, and that's all I need to do. And then the same with the so I've done that with the source, and I've done it with the destination. So it creates the 2 queues. And you'll notice that there's an option here to forward the queue, and there's a number of options there. So you can various different things that you can kind of pass through, including session, and the max delivery count, so on and so forth. Cool. And then go back up, see what's next. Yeah, so the connection details. Okay, so yeah, the connection details uses the same thing, but it just uses this get queue. And once you've got that, you can pull out these authorization rules that we created earlier, and you can sort of you can interrogate them. Although you do have to kind of cast it if you want to get stuff like the primary key out. There's no point in looking to send message because there's no difference. Although it is worth bearing in mind that it's doing that because it's got the 2. It's got these 2 packages. I imagine it's probably considered bad practice to have both packages in the same library. But I'll get away with it because it's a demo. And they created the auto delete queue, so it's exactly the same as we were doing before, but this time instead of forward 2, we're doing auto delete on idle. Like I've said, 5 minutes is the least amount of time that you can do it for. The other thing I forgot to mention when I was talking about his authorization rule, if you give it manage, as with setting this up in the portal, you have to tell it can send and listen. You can't kind of have one without the others, but you can have send without the other two, and you can have listen without the other two. Cool. Okay, let's see if 5 minutes has passed. It has. There it goes. And that it's worth bearing in mind that auto delete on idle is the amount of time that the message queue hasn't been used for, not the last message it was sent to it. So if you keep on looking at the queue and poking it and so on and so forth, it'll stay around. Cool. Okay. Right, performance. How am I doing for time, Joshua? Am I okay?
Yeah, I think you're good. I think we're scheduled for 2 hours, so
Cool.
we're only halfway there. So yeah, as long as you want to take it.
Good stuff. Cool. All right, performance. So it's an interesting thing, the performance. When you're doing sort of, I don't know if you're all sort of C#.NET programmers, but there's this kind of mantra of premature optimization of, don't try and speed something up if it's not slow. With Service Bus, it's like the advice is pretty much that on speed, which is probably not using the right technology if you getting to the point where you're trying to speed it up. Just because it kind of isn't designed for huge amounts of traffic all the time. So you might want to think, maybe I could use something else. Maybe I want to use Event Hub or something else. But as a general guide, peak lock is slower than receive and delete for obvious reasons, because if you peak lock, you've got to call the server twice, whereas receive and delete, you just call it once. And the other thing that's worth mentioning is that some of these things might cause you more problems than they solve. So yeah, caveat emptor is the word of the day, I think, if that is indeed one word. Okay, so the first technique is batch, and it's effectively the target with any technique relating to Service Bus or speeding it up is you call the server less, which causes it to be faster. So what batch does is basically you can send multiple messages at the same time. You can do it on send or receive. With send, if you've got 10 messages, there is no downside to using a batch to send all 10 at the same time. However, with receive, obviously it depends which way you're doing it. So if you're using, essentially what you're doing is you're grouping your receive. So if you've got a peak lock, that lock will expire after a period of time. If you've got a peak lock and you get a batch of 10 items and your lock is for 5 minutes, then you'll probably get to those 10 items in 5 minutes. If your batch is for like 2,000 messages and there's processing in between, you might not get to them in 5 minutes. And at that point, you're going to start getting errors because you've effectively locked that message and it's timed out, and now you're trying to read it. And receive and delete is actually worse because you've now received and lost that message, so that message only exists in your memory. So if anything happens during the process of that batch, you've lost that message, or you've lost all the messages after the one that you've processed. The other thing to bear in mind is that when you request a batch of messages, you're not guaranteed to get them. So if you request 100 messages, you might get 20, 50, 70. So there's use cases for it. You can replay a sequence of events So, you know, if you're sort of using Service Bus as a kind of event sourcing system, you know, I've heard about things like that. Then you potentially would want to replay that as a batch. Yeah, so something that is trying to process hundreds or thousands of messages. You might want to use that. I've given an example as an example of an email spam bot. This is like the archetypal example of, if you want to write these things, then here's how to do it. And I feel really bad, but it is the most obvious and kind of clear example of using queues. So not that I'm suggesting everyone should kind of go away and write something to spam everyone. Okay, and then there's a second technique of prefetch, and this is kind of a batch that you don't control, if you like. So what you're essentially saying to Service Bus is, I'm going to ask you for some messages, and I want you to get some more messages when I ask you for those messages. But the exact same rules apply. So all this is really doing is Service Bus is kind of going and it's receiving more messages that you ask for, and then it's passing them over to you, and effectively they've been received. So if you've got a lock on them, the same as with batch, you've got to kind of get to them. If you've got receive and delete and you don't get to them, then they're lost. Cool. Okay, so demo. Okay, so we've got a performance. Go. So what I'm going to do here is I'm going to send 1,000 messages, and I'm going to do it one at a time, and that's going to take about 30 seconds. And so to distract everyone from the fact that it's taking 30 seconds and there's an uncomfortable silence going on, I'm going to press F5 on this so everyone thinks there's something exciting happening. But yeah, so that should take about 30 seconds. Well, let's go and I'll just, okay. Yep. There we go, 1,000 messages. And okay. Yeah, okay, so about 30 seconds. I'm now going to send the same 1,000 messages, but as a batch. And that's about 1.5 seconds. So it's quite a big difference that you get. Okay. Right. The next thing I'm going to do is I'm going to receive these messages now, and I'm going to receive them individually. So go. And while that's going, I'll advance this poll again so that we can all have a little trivia. And any non-music fans out there will be happy to learn that this is not a music question. So nobody thinks that Facebook have erected a 50-foot statue of Mark Zuckerberg. I definitely think they should do that. I mean, it's like the last straw in it. If only we all knew how much we really pay for it as well. So this is going to take about 2 minutes, I think, to receive all of these messages. And while it's doing, what I'll do is I'll show some of the code. Okay. There we go. Okay, so what we've just seen is the send messages. So effectively, yeah, send messages. So you saw the send message before. I'm assuming that everybody here knows how to use a for loop. So this shouldn't be this shouldn't strike anyone as strange. And the send message batch. So in the framework version of this, there was actually a method called, I think it was send message batch or something. But here it's just an overload. So you basically just build a list of messages up like this, and you just pass that to the same send message as you did when you were just calling a single one, which is excellent in that it kind of fits a lot better into the SDK. But when you're trying to write a talk like this and you're trying to work out how to send a batch of messages, it's not that obvious. So yeah, and the receive messages. So this is what it's currently executing in a minute. And the reason it's so slow is effectively it's receiving the message, each message, and then it's completing the message. That's why I was saying before, receive and delete is faster, because you cut out that line of code there at 126. Okay, so let's go back to there we go. Okay, so 127, so just over 2 minutes it took to receive those messages. So now what we'll do is we'll batch receive them. And you'll notice that's very jerky. What it's doing is it's kind of getting 30 messages, then it's getting 50 messages. But the whole thing is a magnitude faster than doing it individually. Obviously, that wasn't supposed to happen. Remember a legally binding contract that we all entered into? Yeah. So let's do that again and see if it just clears out the rest. Essentially, that takes about 10 seconds normally. It's picking it up now. Cool. Okay. And then the last thing. So this is the you've seen receive. Receive messages. But it's not liking this, is it? Okay. We're gonna skip over this bit. What I will do. So effectively, I'll skip the demo because it's crashing for whatever reason. I'm not trying to debug it now, but so to the receive messages that we had one at a time, we saw that receive and complete, and then we had receive messages in batch. Receive messages in batch is exactly the same thing. So effectively, here what you do is you say, I'm going to receive a message, and I'm going to receive 10 of them, or whatever it is, or in this case 100 of them, or 1,000 of them, and then you essentially you give it a timeout. So obviously what was happening here is it was taking longer than 20 seconds for some reason. And then the problem here is that well, the good thing is you can complete it. So up here you had to complete one at a time. So all we're doing here is we're completing all of the messages at the same time. So we're basically reading all the messages and then we're saying, okay, now complete them all. I don't know whether I'm taking the life of my hands doing the prefetch based on that, but let's give it a go. So let's give that a restart. Okay, so let's bung some more messages on the queue, because I think we might be running out actually. Oh, okay, right, that's gone. And prefetch. Okay, so what we're doing here is prefetch. Now, prefetch ends up being a bit faster, but it's not much faster, and there's a reason relating to things like the message size and the subscription that you're on, and so on and so forth, that effectively means that it can't read ahead as far as you kind of think it's going to. But if we have a look here, what we're prefetch. If we have a look here, what we're doing, so we're sort of saying, okay, we're going to prefetch this number. Again, not guaranteed. In the same way as batch isn't guaranteed, it'll work out what it can prefetch up to that figure, and then set same thing. So I've set a timeout, and then it'll complete them. I'm not sure if it's worth hanging around for that, because it takes about a minute and a half, I think, depending on the way the wind's blowing. But I'll just, while that's happening, I'll talk about the idea of using prefetch and batch at the same time. Again, it's difficult to sort of see how this would be any faster than using batch. I think for absolutely colossal amounts of messages, you might see some performance improvement if you played around with it enough. But yeah, by far the fastest, the biggest change in speed that I've seen is just using batch. But yeah, you can use prefetch and batch at the same time. Let's see if that's finished. Oh yeah, that's finished. Oh, there you go. So yeah, just shy of 2 minutes. So there is a performance improvement. It's just not brilliant. I suppose we should give the prefetch batch a run just for completeness. And that is not doing very much, but while waiting for that, let's see where we are. Okay, so that's pretty much it. Let me. Still running. Okay. So that's pretty much it. The video that I created with the introduction on is here. I'll send these links around in a minute while Joshua is doing the wrap up. But there's a GitHub repo with all of the code on from this talk. I frequently blog here, and I frequently blog about the things that I'm talking about on this talk, although I do also blog about a wide range of other things that might not interest you. And just to remind you, I'm running this, me and another guy running this MiniHack group, which you may or may not be interested in. Does anyone have any questions other than... Oh, that did complete. Okay. So receiving them took about 60 seconds with the prefetch and batch. So again, a slight improvement, but not huge. Okay, any questions?
So quick one, Paul. First of all, just want to thank you for the talk. It was absolutely brilliant. I think we've all got some questions. They're absolutely great. But what I'm going to do is I'm going to stop the YouTube channel there. I'm going to take the questions offline. So
Cool.
we'll start doing the questions in a few minutes. Before I do, I just want to give a massive thank you for everyone who joined the raffle for the JetBrains licenses. So there were 4 people who wanted the licenses, and thanks to JetBrains tonight, all 4 of you will receive your licenses. So we'll get them in an email for you, which is great news. Thanks JetBrains, and thank you TLA for the sponsorship and allowing our group to run this evening through Zoom. And what we're going to do is stop the video there, and we'll take the questions offline. So thank you everyone for joining, and again, comment and subscribe to our YouTube channel. Thank you very much. Any questions?
Yeah, I've got a couple of questions for you. First of all, your use of sessions before. When would I've not tried sessions.